I'll start with introducing myself. That's me, wearing a different shirt, but I can assure you it's still me. I'm in QA since 2013 and already 5 years at Brightest, and I'm serving there as the domain lead functional test automation. And today I've been asked to tell you all about legacy regression automation. So what are we going to cover today? First of all, what's a legacy system? What do we understand? When is a system legacy? And then we go to talk a bit more about how legacy automation is different from traditional test automation. Which challenges are there? And then also a long-term approach, also with some scaling and optimization of test execution and of course, future-proofing automation. And afterwards, there will be some room for questions. So, what is a legacy system? Basically, a legacy system is a bit complex. Usually we define it as it's been built on outdated technologies, architecture, or practices, which is often difficult to maintain or evolve. So the keywords here are outdated technology, hard to maintain, little to no active development, and not easily replaced. Because if it was easily replaceable, then we just get rid of it, right? Usually it also is paired with a lack of test coverage and or automation. It's a system, it's there, it just works. So immediately there's the question, why would you automate a legacy system? Because in the end, the biggest return on investment of automation is in the execution frequency. A test script takes more time to develop than just doing the test manually. So why would you invest in something that's not often tested in automation? Well, basically, there are some things that you might consider. Sometimes it's part of a bigger flow, and the automation then catches issues from surrounding updates. Maybe there's a migration or modernization project ahead of us, where automation can validate everything from the behavior before and after the migration. Also, even though that the manual test sometimes is faster than the development of the automation script itself, sometimes it requires some specific domain knowledge or effort, and those resources are not always readily available. And sometimes there's a lot of documentation that's missing, or it's very old technology, and maybe the guys that made it are already retired at this time. So there aren't always those resources available. Sometimes you also have to have a test that is 100% repeatable, traceable, and documented. And also there, you can argue that test automation is more suited. And also, the full business flow might depend on it. So we want to automate the chain and not all the individual parts. Basically, it comes down to this. If it's critical, touched by change, or costly to test manually, it's worth automating. Now, regarding legacy regression automation. So we defined legacy software as it's usually a critical system, because otherwise we would get rid of it. That legacy automation, because it's based on older technologies or not maintained, or it's lacking documentation, is not always suited for modern test automation. It lacks testability failures, and you can see in the table I put here what impact the test automation could have. Like in legacy systems, the testability is often poor, little to no APIs, very dynamic or unreachable elements, which result in UI changes. They're very unpredictable, and the overall execution speed of everything you put in is usually a lot slower, because test automation doesn't have those modern hooks that it can rely on. If we talk about terms of maintenance, usually it's also high effort and brittle tests. Whereas if you go look at modern systems, usually or hopefully, let's say like that, modern systems are designed for automation. They're API first, so you can leverage them to have API test automation or interface where the tests are much more efficient, much more faster, and so on. But we don't see that in some legacy systems. Modern systems, the UI changes here, they can be controlled with countermeasures. Execution speed can be optimized. Think about parallelization, virtualization, and so on. And maintenance, with modern systems, you have your framework, which can stabilize your test maintenance. You don't have that for legacy regression automation. It's not always. If you look at this, we can actually say like, okay, to counter this, we can implement 3 different best practices for optimized automation. First of all, we have the strategy. So if we have a good strategy in place which identifies the core functionalities that always has to work, then we can leverage that to have a more optimized approach to this. Also a layered automation. Use API testing, database testing, and UI automation together to have that coverage. And don't put everything in one or the other. And also, lastly, a controlled scope. Always avoid over automation. Only automate that which adds real value. Now, that's about the automation, but how exactly is it different? I've had some time to think about it, and I've identified 3 main pillars, which is the architectural constraints, it's not automation friendly, and there's a heavy coupling involved. So architectural constraints, usually if we talk about legacy software, we immediately think like, oh, it's a monolithic architecture structure which lacks modularity. If there's test automation involved, usually it's also based on an old test framework. And that combined with the outdated technology, it often requires specialized tools or workarounds. If you have a very old UI interface, you don't really have something like, let's say, Playwright or sometimes even UFT, which can hook to it. So you have to do workarounds. You can do them, that's fine. There's always a workaround possible, but you have to think about, is it worth the effort? Also, with the not automation friendly, the older style of frameworks, interfaces, which uses technology that hardly connects with those automation tools, that's not making it easier for us. And even more so regarding the coupling, where we have components of the legacy system which are tightly coupled, sometimes even coupled with the test automation, it leads to fragile UI elements and fragile test automation. So again, here we can identify 3 different best practices which can cope with that. First of all, use risk-based automation. You can do those workarounds, you can do whatever it needs to do to make it work, but you have to calculate the risk. If there's higher risk, then it's worth automating that more or putting in that extra effort, that extra mile to be able to automate it. On the other hand, if there's low risk, then why would you do all that effort just to make one tiny thing work, right? If we talk about abstraction layers, that also goes hand in hand with test automation, because abstraction layers, or the introduction of them, might help reduce test maintenance on UI changes. Abstraction layers make it so that if you're using test automation technology, which after a while gets outdated, you can use that abstraction to couple another test automation tool, making everything more up to date, and also always respect the test automation pyramid or test trophy, to avoid over-reliance on UI automation. UI automation will always be more unstable than doing it via a database or interfaces or whatever. So there has to be a good balance, and you still have to do the UI testing, but it has to be a mix, and it has to have that good automation shape, basically. Now, what challenges are there then in test automation or automating legacy systems? Well, I mentioned before, we have first of all, the lack of testability of certain functionalities. There might be no built-in test hooks. There might be a custom or outdated UI components that are not recognized by standard automation tools. Sometimes you even have a terminal-based or a mainframe system with very limited automation support. Tooling limitations. Modern automation tools might not support those legacy technology stacks. Maybe there's also an older environment that requires some emulation or some virtual machines. And since it's always legacy, there's often a documentation gap in libraries or third-party components or test automation libraries. And maybe there's a dependency which is built into the system, which has been deprecated for quite a while, so no active development in the test automation library, so no one actually knows how to use it anymore. And poorly documented tests, they break. If you have to fix them, who knows how to get it working again, which results in a high maintenance cost. And then, as I mentioned before as well, with the lack of skilled resources, you simply have fewer experts available for that outdated technology. It always requires a mix of certain domain knowledge and automation expertise, and if one of the two is a bit lacking, well, that can result in a very high challenge. So basically, what now? So I gave you 6 best practices at the layered automation strategy: control your scope, respect the automation period, have your abstraction layers, and the risk-based automation. And now what? And that's usually the question we get. And if you look at it, we basically have 2 starting positions. First of all, you don't have automation. Second of all, you do have test automation, but also that is legacy. So let's start with the first one. If there's no automation present, and we have those 6 different best practices, we start with layered automation. Start small with those foundational scripts before expanding to UI tests. Also, with the strategy, define a clear goal, select tools that best fit that legacy system. We can then go to the control scope and focus on those high-value test cases first, avoiding a big bang, avoiding the full automation at once. Still respecting the best test pyramid, so prioritize your API and integration tests over those UI tests where possible, and then design everything with abstraction in mind. Use those structured test design to separate test logic from the implementation details. Also there, if you ever need to change tooling or whatever, those abstraction layers can help you do that. And again, with the risk-based automation, base your tests or your test scripts on the business impact and the failure likelihood. If there's already automation present, but also that is legacy, think about, oh, we do have automation, but it's not working anymore. We have 50 test cases, only one of them is passing, well, then it's time to refactor that. First of all, the existing scripts, try to do that same layered automation approach, use modular reusable components, but also of those tests, which you already have, reassess them. Are they still in line with our current needs or our future needs? Because legacy automation, maybe no one has touched that in years. Maybe it's time to identify and identify those obsolete or redundant tests and remove them. Because if they're failing every time you run, why would you run them? Because they're failing because they broke, right? If they failed because there's actually an issue, that's a different story. Thinking about the test automation pyramid, also here, try to shift down those test cases along the pyramid, if possible, and introduce better structuring to make on your existing tests to reduce that coupling between tests and technology. Also here, reprioritize your test coverage based on the system usage and failure risks. Sometimes in legacy component, there are things that aren't used anymore. Well, maybe we don't need to have automation there, or why would we still need automation there? And we have to reassess that altogether. Now, that's the start. That's how we would approach it. But how could we now scale it? How can we improve our test execution? Basically, let's start with optimizing the execution speed, but without sacrificing the necessary coverage. And to do that, we can leverage parallelization and distribution. So instead of running everything sequentially, distribute that test execution across multiple environments, maybe using cloud-based grids or in-house distributed setups. Again, with the risk-based test execution, and prioritize those critical tests based on historical failure rates or recent code changes or business impact, rather than doing everything all the time, every time. A dynamic test selection could also help, where we use test impact analysis to determine which tests are relevant to certain changes, reducing further those unnecessary test runs. Keep the test runs to its score, what it's supposed to test, and not we have everything automated, so let's run it every time. If we talk about terms of improving stability and maintainability, again, try to reduce the UI dependency as much by shifting as many tests as possible from UI down to API or other integration layers. Strengthen test abstraction. I always have to, I like to say this a lot of times, but test abstraction is a solid principle of test automation, that we ensure that the tests themselves interact through test interfaces instead of hard-coded things or leading to fragile scripts. There's also a matter of self-healing and smart locators. We can leverage AI in our automation tools to have more robust element strategies or to prevent certain failures due to UI changes. If you look at infrastructure and execution bottlenecks, that's also something we will need to address. Using Docker, for example, or VMs, or some cloud-based form of test execution to minimize that setup and configuration overhead, and also look at the test data. We need a lot of test data for our test automation. We enter a lot of test data. Somewhere we need to clean this up, because a huge database also prevents us to scale faster. Again, eliminate those flaky and redundant tests. And that's part of the continuous improvement part, because a test automation project is not just a one-off project. You implement your test automation, that's that. No, it's a continuous improvement project. It's continuously refining what you did. And that's basically the thing that leads us to having legacy software in the beginning, because we're not improving, we're not refining everything always. Which brings me with the segue to future-proofing our test automation. Because legacy software wasn't always legacy. Sometimes it just evolves. But in the end, state-of-the-art, cutting-edge technology of today is the legacy of tomorrow. And the only thing we can do to future-proof everything is adding flexibility, scalability, and maintainability. But it must be done from the start to avoid that technical debt. If you have technical debt in your project, it will just keep building and building and building. And then after a while, you're stuck with a huge pile of technical debt, and that opens the door for your legacy. So also thinking about this for future proofing, I've come up with six key principles of future proofing something. And the first where I'd like to start is design for modularity and flexibility. So a modular test design, avoid creating those large monolithic test suites. Modularize your test cases, your components, your test logic, so that all those individual pieces can be reused, refactored, or replaced if there's new technology better suited for them. Use a plugin based or an extensible framework where you build your easy to replace plugins and extensions and updates, because as your system ages, this can ensure you that you continue to add new capabilities without overhauling your entire system. And this is why I told you in the last slide, it must be done from the start. You must start your project keeping this in mind, because you can use your Playwright framework now out of the box, but what happens in a few years? Maybe Playwright is deprecated by then. We don't know that, so we can't risk it. Which then also leads into the maintaining of the abstraction layers. Decouple your test logic from your implementation details. The more abstract your tests are from the actual code, the less likely that changes in one area will require extensive updates in the entire suite. Also, sometimes you start on a project and you base it on something else because you know it works. It's fine, but try to embrace scalable and modern infrastructure. For example, cloud native testing or a good CI/CD implementation. Cross-platform, cross-browser, will always come back as a technical debt. And for example, you might as well use Windows in your organization right now, but it might be that in a few years your test automation is better to be run on Linux servers. Well, embrace that. Embrace your system to be able to do cross-platform that's not tied to one thing. And also, AI is here. It's now. It's here to stay. So try to leverage that. Invest in smart automation tools, for example, with AI. Invest in machine learning if possible. Even if it's just using AI to create your scripts. Don't mean like just copy paste whatever AI is telling you, but if it can help you write faster, better scripts, please use that. Also look at the best practices, adhering to the test automation pyramid, prioritize low-level tests rather than UI tests, and treat test automation as a living object. There has to be a clear owner, a clear team responsible for maintaining and improving, because that reduces the risk of it becoming outdated or neglected, which is often the main issue with legacy automation. And then lastly, document, because there's nothing worse than working with something you don't know and there's no way of telling how it should react. So document everything, and if there's technical debt, which I'm sure there will be after time, document that. Make it sure that it's somewhere visible that, okay, we have this bit of work which still needs to be done. Make it visible before it gets buried behind a pile of more work. And then lastly, there are also some strategic considerations for future proofing. So let's start with adapt to change. And because technology stacks, tools, and framework age, they get deprecated, they stop receiving updates, or they fall behind times. Your automation should be able to move forward without requiring a full rewrite every year. How do you do that? Well, by choosing flexible tools, flexible frameworks. If you use, for example, generic scripting language, think about JavaScript, Python, or use C# or whatever, you're less locked in than with proprietary solutions. Abstract those tools from the logic, and again with those abstraction layers. And also think about, we're gonna need to upgrade in a few years. How can we do this? For example, if you're on a certain version of Playwright, start planning ahead to move to a next version of Playwright. Don't wait until the old version breaks, because if you wait until the old version breaks, you're basically reacting. Reacting is slow, which makes it more likely to be legacy in the future. Reduce dependency on single vendor technology. Avoid trying your entire test automation strategy, tying it to a certain tool or vendor. That might become obsolete or too expensive. Basically, your flexibility is your sustainability. There are a lot of open source tools or community supported tools. Think about Playwright, Cypress, and so on, that evolve fast, have strong ecosystems, but avoid those magic box frameworks. Magic box frameworks, this does everything and only that guy knows how it works. You put in a test object, you get out a test report, learn from that, understand it, and train your team in that tool, and even train your developers in it. Because your test automation effort is not a solo project. There needs to be collaboration between QA, between developers, between the business side of it. Just because it's sometimes hard for test automation to do a certain thing. And if your developers don't understand why it might be hard, then it's hard for them to understand why they should do extra effort. Because can't you do it like this, or can't you do it like that? So foster that collaboration between teams, make everyone understand why they did something. The other way as well, right? If testers say like, oh, but we need this and that from developers, Maybe it's just not possible from the developer side, which leads to frustrations. So do join the retrospectives. Regularly inspect what's working, where your test coverage is lacking, what technical debt is growing, what went wrong, what went well, what didn't go so well, and then try to collaborate that and establish those long-term goals. Because you shouldn't be only focusing on those test automation problems of today, but you should rather focus to build a strategy that aligns with how your product, your teams, your technology will evolve in the coming years. Set certain milestones, for example. Because if you don't set those long-term objectives, your automation might solve your current problems, but again, will become obsolete when the technology stack evolves, which again will turn it into legacy. That concludes the presentation part. I went a bit fast there because I felt like I was on a roll. So if there are any questions, please feel free to send them either via the chat or just speak up. And thank you for your attention.
Any questions?
Well, thank you for the presentation. I have one. Do you have anything in particular that you can say on proprietary systems? So not just legacy, but also proprietary, how you could handle those ones?
Proprietary test automation systems or the system themselves that you want to test automate?
The system itself is proprietary.
Yeah.
We need to start testing. It's legacy, but it's also proprietary.
Yeah. Well, what you could best do then is like chart. First of all, what are your goals? What do you want to automate and why? And then try to look, how can we achieve this? What do we need? Is it via UI? Is it via some interface? Is it with an old card system, for example, like way back? And then if you have that and you have that puzzle, then let's start looking at tools. Which tools can do everything we want, or do we need a combination of tools? When you have the tool selection, then start a small proof of concept. You have one or multiple end-to-end cases to do it. You try one in a proof of concept, then you prove that the tools you selected can handle your automation, and then start building.
Okay, yeah. Sounds logical. Thank you.
Any further questions?
I do have one.
Yes.
Let's say if you start without any test automation at the moment, are there any high-level suggestions or tools which you would advise, or you would say those will work for legacy systems?
Well, it really depends on how your legacy system is built. Usually some tool which I always refer to as that's the crowbar of my test automation. If it doesn't work, I'll fix it with the crowbar, is UFT, for example, because it supports a lot of legacy UI systems. But yeah, can you tell me maybe a bit more on how the system is made, or is it UI, or is it interface based?
It's coded in .NET. Yeah, and it has some indeed. Yeah, you have several functions behind buttons and configuration, but it's a lot of combinations of configurations and yeah, and buttons. So
complicated stuff.
Yes, indeed.
Well, for is it a desktop application? Or,
Yes.
Yeah.
It's running on Windows. Yes.
Yeah, so desktop applications are always a bit tricky because there are few companies which actually can do a proper test automation on desktop apps. And unfortunately, because they know there are almost none other competitors, they charge a lot.
Okay.
But you get a lot of value from them. Another way to do it, for example, using open source is called 𝗕𝗕𝗄𝗃, which basically automates your desktop to click on or interact with reference images. So basically, you take a screenshot of a button, you say, please click that reference of that button. But downside is if you have different resolution, because it has to be pixel perfect, or you have to write something around it to make it less pixel perfect. And then you're starting to build solutions on solutions, and you basically end up with a patchwork and not a well-lined solution. But if it's .NET based and desktop, I would suggest looking into UFT or UFT developer.
Let me quickly share my screen again while I thank 𝗕𝗵, of course, for your wonderful presentation. Thank you, 𝗕𝗵, and thank you all for joining, and hope to see you next time.